to the website, tootalltoby.com. You're going to want to go there. You're going to want to sign up for a free account at a minimum. Maybe while you're there, after you sign up for that free account, hey, upgrade to premium. Why not? You're already there. So go to tootalltoby.com, sign up for a free account. You're going to see here we've got this featured practice model from last week. We posted this one. We made it a featured practice model for last week. Well, now we are going to refresh the page, and you should see a brand new featured practice model here, 250503. And so with the release of that brand new practice model, you guys are trying to solve this model on your own live. I am going to try and solve this model here for you as well using Onshape. And we're going to access this model by going to tootalltoby.com, saying click here to get started. And we're going to try and do this model right here. We just released it 10 seconds ago. 250503, and it's here in our featured challenge models. So these are models where all users, even if you have a free account at tootalltoby.com, can access the functionality of premium, of practice models premium. So normally this model is gated, but today it is available for everyone, and it'll probably be up there for about a week. So we're going to say click here to practice, and no one has solved this thing yet because we just released it. So let's say click here to begin, and go. So what is the mass of this multi-body part or assembly in XXXX grams? Tolerance is plus or minus 2 grams. So both of these parts are made from plain carbon steel. We can see the clock is running down here, but even though the clock is running, I think it's always good to start out by coming up with a game plan. So one of the first things you're going to do is you're just going to kind of get acclimated with the geometry of the drawing, right? If somebody from the shop gives you a drawing, or if a customer's got a new invention and they give you a drawing, you're going to have some questions like, when this pipe fits into this hole, are they the same size or are they different sizes? And is this pipe here flush to the top surface of the bracket, or is it flush to the bottom surface of the bracket? And are they made from the same material? Well, we already kind of answered that one. They are made from the same material. They're both made from plain carbon steel. And maybe another question you'd have is, is this lower part sheet metal? Does it have to be sheet metal? Well, we can see here there's a note that says the base may be modeled as sheet metal, or it may be modeled as a thin-walled part, whatever you prefer. I'm going to do it as sheet metal in Onshape here. So now we see, if we're going to kind of go back to this first question here, which is this diameter the same as this hole? Well, if we look here at the top view, we can see that there's a call out on the top view for the hole at 87 millimeters through. And then there's a call out for the pipe just below that at 86 outer diameter and 70 inner diameter. So now we know that there is a 0.5 millimeter clearance per side. So 1 millimeter total for that diameter clearance for that pipe to move through. And then is the pipe flush to this bottom face? I think it's safe to say that it is. You can see here that it looks like it's running up flush to that bottom face of the bracket. So not the top face, but flush to the bottom face. And then also, if we look here in this front view, we can see that there's no extra line happening down in this lower region here. It's like there's one single line that just kind of comes across straight there. So that's another indicator that that pipe is just moving down and ending up flush to that bottom surface. So that acclimation has to take place whenever you're looking at a semi-complex drawing, a drawing of a multi-body part or a drawing of an assembly. Whenever you get a drawing from a customer, you just have to take a minute or two and kind of get acclimated with the geometry of the drawing. So now we can get into our actual game plan. And I think the game plan for this, for me, is going to be to create this kind of sheet metal part first, and then I'll create this pipe part second. And so to create the sheet metal part, I think what I'll do is I'll create a rectangle here that's centered on the origin. So we're always thinking about what's our first sketch going to look like and where is our origin going to be. Maybe I'll include this hole that's running through the diameter 87 hole here in that first sketch as well. And that sketch is going to be at 150 by 150. And then I'll take that sketch and I'll turn it into sheet metal. I'll just make it sheet metal right away in Onshape. And then once I've got that geometry extruded as sheet metal, I'll go in and I'll create this shape here, this kind of like tombstone cut shape here, because that's going to give me the location of this flange that's sticking down here. So I'll make those cuts there. And then once I make those cuts, then I can get in here and start creating the geometry of this flange. So we can see this flange is 30. We saw that in the top view by 25. And it's got some chamfers here on the corner. And then once I've got that one single flange, well, then what I can do is a pattern. This model is symmetric in two directions. It's a square base. So instead of doing this as a mirror of some sort, what I could do is I can do a circular pattern. So we can take that those cuts, and we can take that flange and we can make that into a circular pattern and just circular pattern that thing all the way around. And then once I've got that circular pattern, it's pretty much an easy finish there. All I've got to do is add these fillets, add these holes, and then extrude the pipe. And I'll make the pipe a separate part, and that should pretty much take care of it. So we took about 4 minutes there to come up with a game plan. I see some people are coming into the chat with their answers. That's awesome. Maybe those answers are even going to start showing up in the top 100. And so we'll see that in a minute, but I'm going to save that. I don't want to spoil it for anybody. So what I'm going to do is I'm going to jump into Onshape here. I'm using Onshape's free offering, onshape.com/free. And so that means that once I create this document, it will be created in the public space. And that means that anybody who wants to can go into the public space and search for this document name, and you'll be able to see the way that I constructed the tree here in Onshape. Let's bring up our keyboard cam and let's get into modeling this thing. Create document 25-05-01 leg mount, and this is in the public space, so anybody who accesses Onshape can search for this document. And we're going to go up here to this hamburger menu up here, and in that hamburger menu, we're going to make sure that we're using the correct workspace units. So my default workspace units are millimeter. That's the units of this document. Grams, that's the units of this document. So I'm good to go here. Of course, if you want to change that, you can change that in your profile up here, your defaults, or you can change it per document using that hamburger menu. And then I'm going to go top plane, begin a sketch, S key here, begin a sketch, N key to get normal to, S key, I'm going to go to sketch a rectangle. I'm going to single click here, I'm going to move my mouse, and then I'm going to hold Alt. So this is a kind of a cool shortcut. When you hold Alt, what you can do is you can make a square instead of making a rectangle in Onshape. So I'm holding the Alt key on my keyboard, then I'm going to click to drop that corner of the rectangle. Now I'll let go of Alt, and I'll type in 150, and look at that. That gives us a square instead of a rectangle. So now we are set up here with a square instead of a rectangle. Now we can press the S key, jump into the circle command, and we can create a circle here with a diameter of 87. The through hole in the sheet metal part is going to be 87 millimeters. And so now, whoops, I didn't mean to make that circle, just Control Z there. So this is what your first sketch should look like here. And now we're going to take that geometry, we're going to exit the sketch, and we're going to go into our Onshape sheet metal model tools. And so here in our Onshape sheet metal model, we're going to say we want this to be a thicken, and then we can just pick here inside of this region, and that lets us thicken this into sheet metal. Now, if we go back and we look at the drawing, we can see here on the drawing that the default sheet metal wall thickness is 4 millimeters, and the default inside bend radius is 4 millimeters as well. So here in Onshape, what we're going to do is we're going to say that we want to make sure that we're using 4 millimeters for our wall thickness, 4 millimeters for our bend radius, and then this could either be going up or down. I think I'll just make this going up, and that way later on I can create the sketch for the pipe right here on the top plane. So it just makes it a little bit easier for me to make that sketch of the pipe later on. So 4 millimeters up here, 4 millimeters in this direction. I'm going to hit the green check mark, and there we go. And now I'm ready to move on to the second step in my game plan, which is to create those little slots on the side here. So S key, begin a sketch, N key, get normal to, S key, create a line. So I'll just do a line here. And we could do this with the slot tool, or we could click line, arc, line. Either one works. I like the slot tool here. So I'm just going to drop in a line, hit escape, click on that line, and then I'm going to go up here to where you've got the offset entities command in Onshape. You fly out this menu, and that's where you're going to find the slot command. So make this a slot here. That's going to have a width of 6 millimeters. So 6, and then I'll just left click to finish that slot, and then I'm going to hit escape, and I'm going to right click on one of these lines in the slot, and I'm going to choose select tangent connected edges. So that gets everything in the slot, and then I'm going to click mirror, and then in Onshape where it says select a mirror line, I can just pick this plane here, the front plane, and I can just mirror right over that plane. So you don't actually have to sketch a line to mirror about. You can just mirror about that plane. And so now I can S key dimension and create a dimension here from line to line with a distance of 30. This is all shown in that top view. And then a distance here from this line to the arc, and that goes out to the max tangency point of the arc, and that's where that 15 dimension is shown. And so now I'm going to S key extrude, and this will be a remove, and that remove is going to go through all. And boom, there we go. That gives us that geometry. And so now I'm ready to move on to the flange feature. So for the flange feature, I could just pick the flange command here, flange. So this is in the sheet metal fly out, all the sheet metal commands are here. So flange, and then I'll pick on this edge here, and you can see that I can reverse the direction of that flange. I can make sure that the flange is going down. It's going to be going down to a distance of 25, and then I'm just going to look at this thing in a front view. So I'll press Shift 1, that rotates me into a front view, and you can see here that the edge of the part is coming down, and now we're ending up one material thickness to the outside of the edge of the part with this flange. So here's the edge of the part, here's the flange. It's like that, those two probably are flush, and then I've got one material thickness here to the outside. Well, if we look at the original drawing, that's not what we have. In the original drawing here in the front view, the edge of the part is flush to the flange. So in any sheet metal module, whether you're using Onshape or SolidWorks or Fusion, you're going to see that there's going to be options to control where that flange ends up. So flange alignment inner, flange alignment outer, see, look, that one's flush, flange alignment hold line. You get all different results here. So for this one, we're going to say flange alignment outer. We're going to hit the green check mark, and then the distance from this face down to this face down here should be 25 millimeters. And so if I just click on those two and then I look down here, you can see that that distance is 25 millimeters. So it's just like a quick check just to make sure that that distance is correct. Just do a quick check there. So now that that check is complete, I'll click in the background so nothing is selected. I'll choose the chamfer command. This chamfer is going to be a distance of 4 by 45, and that's going to be applied here on this edge, and that's going to be applied here on this edge. So chamfer 4 by 45 on those two edges. Looks like I'm running into a little bit of an issue here where that chamfer doesn't seem to want to complete. So I think what I'll do here is I'll cancel out of that, and instead of using the chamfer there, so this is, I like this model because it lets us kind of experiment with some things that maybe don't go as planned in Onshape. Instead of using the traditional chamfer there, what I could do is I could fly out this menu here, and from this menu, I could choose the option for corner break. So I'll choose the option for corner break here, and I can either make this a fillet or a chamfer. I'm going to make it a chamfer with an equal distance of 4 millimeters, and then I'm going to click on this this edge here or this point, and this edge here or this point. And you can see that there Onshape is able to go through and is able to break up those corners using that corner break option. So in Onshape, when you're in sheet metal mode, you can get to the end of sheet metal mode and you can choose it's called like finalize sheet metal mode. And then you're going to, here it is, finish sheet metal model. And once you do that, then you're going to be able to access some of those more commonly used geometric commands. But while you're still in that kind of sheet metal model mode, some of those solid feature commands may or may not work. Like cut works fine, but chamfer maybe will give you a little bit of a hiccup. So instead, you can use the sheet metal tool for corner break, and that way you can generate that chamfer. So this is a great model because it helps us to kind of see some of those little hiccups we might run into, and it helps us experiment and kind of work around those options. Matab's showing that you can use a face when you do a corner break. Let's try that in Onshape. So I'll double click on the feature to edit it. Double click here on the feature. I'll press the space bar in the background to clear selections, and then I'll just pick this face here. And nope, doesn't look like it's going to let me pick that face. How about a window select here? So I can do a window select and get both of those corners pretty easily. That's probably what I would use instead of just picking that face there. Yep, good call, Matab. So now that we've got those features in place, let's jump into our circular pattern. So we go in here and we say circular pattern, and we're going to create a circular pattern of features. So here we go into features, and we're going to say that we're going to pattern the cut that we created. We're going to pattern the flange, and we're going to pattern the corner break. And then we're going to go here to where it says axis of pattern, and we're going to pick this edge of the edge here of the circle. And we see that we sort of get a preview, but the preview is not coming up. Now, for me in Onshape, anytime I run into an issue where the preview shows up in red and I'm doing a pattern, the first thing I do is I hit this option here for reapply features. And 9 times out of 10, that'll resolve the issue. But in this case, it's not resolving the issue. And this happens sometimes in any 3D CAD system where you'll run into an issue where you try to do a pattern and it just doesn't work. You can't seem to feature pattern. Now, The reason why you cannot feature pattern, it depends on the CAD system that you're using. It could be because of how different features are coming together. It could be because of edge IDs, face IDs. It could be for a variety of reasons. But again, the reason I like this challenge and the reason I was excited to live solve this one is because we get to show you some workarounds when you run into an issue like this. And the most common workaround when a circular pattern of features doesn't work is to instead do a circular pattern of a body. So if I click here on the circular pattern for the feature, I'm going to delete it. And then I'm going to click on this face here and I'm going to go S key, sketch, N key to get normal 2. And then what I'm going to do is I'm just going to create some geometry to kind of cut away 3/4 of the model. So I'm going to create some geometry that looks like this. And I'm just going to kind of cut away 3/4 of the model here using an extrude. So I'll do extrude here and I'll do remove and I'll make that through all, kind of cut away 3/4 of the model here from that top surface. And then what I can do is I can do a circular pattern. And when I go to do the circular pattern, I'm going to say that I want to pattern the entire part. Instead of features, I want to pattern the entire part. So I pick the part here and then I say for my axis of pattern, I'm going to pick this edge here. And well, at least I'm seeing a preview, but not quite what I wanted. Right? Not quite what I was hoping for. I'm ending up with only half of that tab there. So what did I do wrong? Well, what I did wrong here, and this is again why I really like showing this model here in the live solve, is a lot of times you think like, okay, I'll just cut it into 1/4 and then I'll pattern that 1/4. But the thing is, we want to cut it here. We want to cut it like this. Because we want to basically keep everything along this edge. And then we just want to make a pattern of that in the 4 locations. So I like this model. You know, this model is a cool example because it reminds us of a lot of different lessons. When a feature pattern doesn't work, you could try and do it as a body pattern. But remember to think about what exactly it is that you're trying to pattern. So if I go back here to this sketch, I'll just delete the whole sketch and recreate the whole sketch. Instead of creating the pattern the way I created it, what I could do is I could start here at this corner, come down here to the middle, come down here to this corner, come over here to this corner, up and over. And then I can choose to remove all of that geometry. So I'm doing that cut. Here you see what that cut looks like. I'm cutting away 3/4 of the model, but I'm cutting it away off of a 45-degree angle and then a 90-degree angle. And the reason that 90-degree angle works is because it's a square. I started with a square, so it works in this case. If you didn't have a square, this might not work as clean. But now what I can do is I can go into my circular pattern. I can say I want to create a pattern of the entire part. So part pattern here. Here's what I want to pattern. And then for my axis of pattern, I'm going to choose this edge right here. And look at that. That's looking pretty darn good. I'm going to say that I want that to be an add so that the sheet metal model is merged together. Hit the check mark. And there we go. There's our sheet metal model. If we go over here in Onshape to our sheet metal tab, you can see that it shows us a flat pattern. That flat pattern looks exactly like what I was expecting. So the circular pattern worked. The flat pattern looks good. This is all looking good here. This is exactly what we were hoping for. And so now we can go in and we can just add the final features. So we could S key here. Maybe what I'll do is I'll make a sketch here. So pick this face, S key, begin a sketch, N key, get normal 2, S key, begin a rectangle. Single click here, move my mouse, hold Alt, right? Because Alt is going to give me a square instead of a rectangle. Then single click out here, let go of Alt, and I'm going to type in 100 because that's supposed to be the location of my holes. And then when it comes to creating those holes, this is a little trick I learned from the chat a few weeks ago. I can exit that sketch. I can just click on the rectangle, just click on that sketch 4 there in the tree, so it's highlighted, and then I can come over here and click the hole command, and look at that. Onshape automatically adds holes at the 4 corners of that rectangle. Yes, I like it. So this is going to be a simple hole, and the diameter of this hole is going to be 16, enter, and enter, and oh yeah, that looks great. And so now the final thing that we have to add is our fillet. So we go S key, fillet, we pick on this edge, this edge, this edge. And then for this one, I'm going to use the tilde key, this key up here kind of above the tab key on your keyboard. So you see how I can just take my mouse out here, kind of put my mouse over the area where I think that edge is, and then I can tap this key, and it lets me pick right through the model and pick that edge so I don't have to rotate the model. And those fillets are going to be 15 millimeters. The hole is 16. The fillets are 15. And there we go. That's our base. So now all that's left is our pipe, which is going to be very simple. Top plane, S key, begin a sketch, N key to get normal 2, S key to sketch a circle, single click here, move your mouse, single click. That circle is going to be 86, enter, single click, move your mouse, single click again. That circle is going to be 70, enter. And now we're ready to take that geometry and S key extrude, and that is going to come up to a height of 114. 114 for the height of that pipe. And look at that. That is looking good. We can press the P key to hide our planes. We can come over here, pick part 1 and part 2 from the parts list, right click, and we can say assign material for 2 parts. And this material is going to come from the custom Too Tall Toby materials library. And for that custom Too Tall Toby's materials library, we're going to go down here to plain carbon steel. We're going to hit the green check mark, and then we're going to come over here to the lower right corner. There's this icon, looks kind of like a set of scales. That's your mass properties icon. We pick this body, and we are coming up with a mass here of 2274. So we're going to go back into the Too Tall Toby app here. The clock is running. We've been going for about 19 minutes now. So let's give this thing a shot. 2274, enter, and oh yeah, we did it. We got it correct. Oh yeah, we like that. So 2274 is the correct answer, 19 minutes and 19 seconds. And upon submission, your time of 19 minutes and 19 seconds will be awarded 1 point on the community scoreboard. So we say submit, and congratulations, your answer was within the specified tolerance. So because this is a Practice Models Premium, or at least a preview of Practice Models Premium, we could do try again. We could get in there and try it again and see if we could do it any faster. We can also now click on the top 100 and we can see who was the fastest person to finish this model. And check it out. It is none other than Otse getting in here, North Macedonia, with 4:10 as his time. Wow, wow, wow. It took me 19 minutes. It took Otse 4 minutes and 10 seconds. It took MCGA 4 minutes and 31 seconds, having never seen that model before. Going through and modeling that up for having never seen it before, that is absolutely screaming. We're going to see Otse this Friday, competing this Friday in the tournament. We're going to see Ricardo Salado competing this Friday in the tournament, 5 minutes and 4 seconds. Wow, wow, wow. We're going to see Metab again. We saw him last week, 6 minutes and 20 seconds. We got Rambro's Workshop, the world champion of 3D CAD speed modeling, in here with a time of 7 minutes and 3 seconds. Very, very impressive. We got Isaiah here coming in with 15 minutes and 19 seconds. And then, of course, we've got Nikola Tesla bringing up the rear here, 19 minutes and 19 seconds. So congratulations to Otse getting in there and getting that answer correct and getting the fastest time on our top 100 leaderboard. Well done, my friend. And that's going to earn you a point on the Model Monday